Chalo. So till now, what we completed in linear regression? Tell me, what of it? Hmm. First definition of linear regression. Definition of linear regression. And the second one, that linear regression formula. Linear regression formula. In that we have simple linear regression, simple and multiple linear regression. Simple and multiple linear regression. And then we understood our main goal is, what our main goal is? Identify suitable coefficients. Suitable coefficients in order to reduce the error, correct? Reduce the error. For that we learn many things. What we learn, that is, we learn about error. We learn about that squared error, SSE, sum of square errors, and we learn about that MSE, mean square error. We learn about RM, root mean square error, and we learn about the loss function, and we learn about the cost function, correct? And then we find beta naught, beta 1 coefficient formulas, right? Coefficient formulas. So the method is called what? OLS, ordinary least square method. Once we find the coefficient, we done the interpretation. So what is the meaning of beta naught? What is the meaning of beta naught? And what is the meaning of beta 1? That's the interpretation, correct? Till now we have done. And next also we done that error, residual standard error, RSE. RSE will give the average deviation. Average deviation from true regression line. Even though that is the regression line is perfectly going, but still I have seen some deviation with the actual values. How much average I am seeing with the actual value, that is called RSE, residual standard error. So what is the RSE formula? What is the RSE formula? Under root. It is same like standard error, right? Same like standard error. RSE is equal to under root RSS by N. RSS by N. So what is RSS generally? Residual sum of squares. Residual sum of squares. RSS. What is the formula? Y minus Y bar. That is the RSS, right? That is RSS. RSS nothing but SSE only. Just take the formula. This one. This is RSS. Yeah. Just look at that 30 seconds about this. Definition of linear regression. Everyone is good, right? That is linear regression formula you already know. Beta naught plus beta 1 into x1 plus beta 2 x2 and so on. Simple means only one variable, multiple means multiple variable. And what is your main goal in the linear regression? Identifying the suitable coefficients. The coefficients we are calling weights in the AI language, right? Deep learning and AI, we calling it is called weights. So now here error. Error is very, very important. That is, we calculate the error formula, actual minus predicted. In any data science, any machine learning, error means what happened? Actual minus predicted. But when you do the sum of all the errors, you might be get 0. That's why what we are doing? Squaring. That is called sum of squared errors. If you want to take the mean, that is called mean square error. If you want to apply the root, that is called root mean square error. Loss function is a single error is nothing but a loss function. Combination of all errors is nothing but what? Cost function. And we find the coefficients also, that is which method is called OLS. OLS means what happened? Ordinary least square method. We done partially differentiation of the cost function with respect to beta naught and partially differentiate with respect to beta 1. Next we done interpretation. Interpretation what happened? If I increase 1 unit in the x and y will be increases by beta 1 times. Correct? That is called beta 1. And beta naught is nothing but what happened? If you opt the input variable also, our constant income, constant is how much we are generating, that is called beta naught. Now RSE, the average deviation from the true regression line. Can you please confirm the chat? Everyone is good, right? Utkarsh, Ravi, Suresh, Priyanka. Everyone is good, right? Arun. Yeah. Shankar, you are calling me, you called me, right? Today we will discuss. Okay. Now, so here, this RSS is nothing but it is talking about is a error kind of, right? Generally, RSA is talking about in terms of formula, talking about error, talking about error, correct? In terms of formula. So that's why error is nothing but a negative term. Error is nothing but a negative, not positive vibration, right? It is a negative vibration. Correct, Srikanth? Error is a negative vibration. Negative vibration. So that's why it is called, this kind of approach is called lack of fit. Lack of fit. Okay. Fit means how much your line is fitting. How good your line is fitting. You need to find the good line fit, right? You need to line the good line fit. This is a lack of it. How much your fitting is lacking. How much your line fit is lacking. That a deal about what? RAC. Lack of fit. Lack of fit. So fitting is nothing but generally, fit is nothing but we are always looking about that. How good our line, right? How good our line, which means how good our line is passing through actual observations. Actual observations. RSC is nothing but how much it is lacking. RSC will tell about how much it is lacking. How much it is lacking. Simply. How much it is lacking. Which means the line. How much the line is lack. That's why it is called lack of fit. It is called lack of fit. And RSC will explain about only about in terms of outputs only. RSC will talk only about outputs. Outputs. Nothing but actual versus predictions. Actual versus predictions. Actual versus prediction. That is what RS. Correct? The formula you see? Here is actual is there, here prediction is there. Dealing about only outputs. Dealing about only outputs. You never discuss about the your variables. Which variable is important, which variable is more impacting. That is not discussing RSC. So that's why it is a negative. It's a negative vibration, lack of fit. So RSC will take only this is very, very important, ma. There are so many metrics will be available, right? This is one metric, RSC. But what is the drawback of RSC? RSC will talk only about the outputs. Is a drawback. It will never discuss about the inputs. It will never discuss about inputs. Will talk about the only outputs. It will never discuss about the input. So that's why we are one more method is there. Tell me what is that? Wow. Everything. How can you know everything? Venki? Hmm? So that is called R squared method. R squared. Tell me. Tell me, Venki, what is R squared? Tell me something. Wow. R squared method. Before going to R squared method, I want to talk about three things. Y average, Y predicted, the Y actual, Y predicted, and Y average. Y average. If you remember, we started our use case. If you doesn't know anything, we'll take average, right? Generally, we don't know any formula, anything. The NABI approach, what we'll do? Generally, we'll take average. Average is like a baseline. It is a kind of a base. Average is base. You're not a data scientist, you're nothing. Nothing, I don't know anything. So I'll just do what I will do, immediate calculation, average. And that only you have taken, right? Like this. What you have taken, Saurabh? The starting approach. What we have taken starting approach? Y is equal to TV plus newspaper plus social media. Like that we have taken. It is nothing but average. If you divide it by n, what happened? Nothing but that is the base, right? That is the base. We started with then we went with weighted average actually. Then we went with what? Weighted. We apply the weights and we apply the weighted. That's called weights. So then now what happened? Your predicted is now become like this. Your predicted will become like beta naught plus beta 1 plus beta 2. Like that it is happened, right? Beta 2 and here x1, here x1, here x2. Like this the formula will be happen. Actual will be anyhow we have a actual will be available. This is generally a base. Average the base, which means you see here, so this is the x-axis and this is the y-axis. Suppose this is your line. This is your line. Your line is going like this. This is your regression line. This is your regression line. Now, if you don't know data scientist, then you take what? Average you will take, right? This is the average line. It is like a average line. The average line. So this is a generally a regression line. It is this line will give what? This line will give what? Predictions. This line will give what? Predictions. This line will give generally a predictions. YP. Some people will talk about that Y cap. What they will write, ma? Y cap. This is the notation some people do. Y cap is nothing but predictions. Always. They will not write Y underscore P. They'll simply write what? Y cap. So Y cap is nothing but predictions. Remember always, Y cap is nothing but predictions. So Y cap, nothing but a predictions. Predictions. Similarly, yi is nothing but an input, actual input, actual. Similarly, yi bar, what you can write bar. These are the notations. This is called average value, average output value, average output value. That is called average output value. Give me 1 minute. Yi is always input, no? Yi is actual output. Not input means that. Don't think like that. Not input. Actual output. Actual output. It is the prediction, model predictions. It is the model predictions is the average output value. These are the notations. These are the notations. One minute. Just message something. So, why at 9:30 only is pinging? Now, this what is the value? This is called y bar. Y bar. This is what y cap. This is the y cap and this is y bar. Y bar. Now, for corresponding x, some observation here. Okay, some corresponding x observation here. Now, if you see your output is predicting, your predicting is this. Suppose this is some x I bar is there, some value is there. If you don't know machine learning, what is the average value will take? This point average value will take, correct? Now you know machine learning, this point will take what? Output. That means this point. This point is nothing but y cap. Can I say y cap this is? Can I say y average this is? Y average. There is some input will be available. Think like that. There's some input will be available here at this position. What will be available? Input. And so for this xi input, the actual output. This is the actual output. Think like that. This is the actual output. It is the actual output. The three are there. The three are there. Actual output yi. So for xi, you have what is there first? Yi is there. Pakka? Understood? You are not a data scientist, so you assume that average value might be the output. What is first output? Average value. Now you learn the data scientist, you perform the regression line, then y cap is your output. Y cap is your output. Understood, everyone? Any doubts in this? Huh. Now see here. What is this y cap? When we will get model predictions? After knowing the regression, after studying the data scientist. What is this y cap? Average output value, anyone can do that is. Okay, my father also can do the average, right? But I only can do what? Model prediction, correct. Now, anyhow, for every xi input, what will be output will be there? Actual output. So three values, yi cap, yi and yi bar. Any doubts in this? Tell me now. That only I have written. For xi, this is the original output, original value. That is what? Yi. And for xi, this is a y bar average. For xi, this red line will give what? Y predictions. So generally, we have a formula will be there. We have a formula will be based on the formula. People will modify the things like this. SST, SSR plus SSE. SST, sum of square total. Sum of square total sum of squares is equal to sum of square residuals plus sum of square explained. Sum of square, these are total. Sum of square total equal to sum of square due to residuals and sum of square due to explained, unexplained, that is. That's nothing but a average. Sum of square residuals. Sum of square residuals. Chalo, this is A, this is B, this is C. Okay. Can I write A minus C equal to A minus B plus B minus C? Tell me, my friends. A minus C equal to A minus B plus B minus C. Can I write this or not? Say it. A minus B plus B minus C. What is A? Y I minus, what is C? Y bar equal to, what is A? Y that is actual. What is B? Actual minus predicted, no? Actual minus predicted क्या होता? Residual होता? Residual? Actual minus predicted plus, what is B? Y cap. Actual prediction and your average prediction. Y bar. So this is nothing but a explained thing. How much deviation you are saying, that is explained. And this is nothing but a total. That's why they are saying that total equal to residual plus E. Again, I'm repeating, just see here. What they will write? Sum of square total equal to sum of square residuals, sum of square explained. So SS total equal to total sum of squares. Total sum of square of total. Sum of squares of total. Or you can get total sum of squares also. Total sum of squares. Total sum of squares. SS or residuals is nothing but sum of square due to residuals. Residual sum of squares. Residual sum of squares. And SSE explained. SSE. Explained sum of squares. Total sum of squares equal to residual sum of squares plus explained sum of squares. I will add the formula now. Now look at very, very carefully now. I'll just write this exactly here. SS total equal to total A minus B. What is A minus B here? Yi minus Y bar. So Yi minus Yi bar. Actually, I will be the other, but
This meeting is being recorded.
This one. This one you read, right? This. Only this. Let me complete the formula, okay? Alright, not coming. I'll copy this somewhere. Why that sound, irritating sound is coming, Sravya? Hmm. Sorry, why it is not coming? Make selection first. We'll do okay, I will do like this only then. Chalo. Y I minus y bar whole square. This is nothing but SS total. And next, do you already know actual minus prediction? But you know what is actual means yi that you already know. But y predicted what we are written? Y cap. Y cap. And this is nothing but now y cap minus y average.
This meeting is being recorded.
Yeah. For every xi input, we can get 3 outputs, correct? First one is what? Actual. First one is what? Actual output. Second one is what? You doesn't know data science. Then who will come? Average. You know the data science. Who will come? Prediction. Clear? Now this diagram, if you see this diagram, yi minus y bar is nothing but total. Y minus y bar is nothing but what? Total. That is called SST. Total sum of squares. Now, if you want to get yi minus y bar means simple trick is what? Yi hither, y bar here is mean, no? Here. Why write this? Both are same. It's a mean. The mean. Now you see this. This is everyone knows this is. This part is everyone knows. Correct? What is this part? Actual minus predictions. Actual minus prediction. Who is that? RSS. SSR. SST equal to SSR plus SSE. SSE is nothing but how much is deviation between the your without data science, after data science. Simple way. How much deviation? This is explained error. What we call is called explained error. Explained error. That is called how much your deviation. Y I cap is nothing but after data science. Y bar is nothing but before data science. Explained error after data science, after you made linear regression line, and before after linear regression line and average value. Take that, not before. Average value. This is called explained. So sum of square total equal to sum of square residuals plus sum of square explained. So this is very, very important. No? Again, I'm repeating. What is the formula? Sum of square total equal to sum of square residuals plus sum of square explained. Pakka? Sum of square explained means the difference between before the data science, after the data science. You remember that. That's it. Okay. Nothing to worry about that. But residual already know. What is the residual? Actual minus prediction. So actual minus prediction plus that is one error. And before data scientist, after data scientist, what you are getting error, that two errors is called what? Total error. The two errors is what called? Total error. That is called sum of square totals equal to residual sum of squares plus explained sum of squares. That only. Explained means you are not data scientist before 1 month. So if I give this question, what you will take? Take the average. Okay. That is the first your base model. Now what I said, Saurav, don't take the average. Now I already thought to linear regression, that apply the linear regression. Now you apply the linear regression. By applying the linear regression also you will like get one value. So before applying the linear regression, you will get one value. Now you are comparing both. You're comparing both. And that is called SSE. Now you see here, y I cap is nothing but what? Prediction. Prediction, when you will get prediction? After the linear regression. Y bar, when you will get y bar? You are not applying the linear regression. Before you taken the average. How much is the difference is there? How much is the difference? That is called SSE, sum of square explained. Now this is actual value and this is the prediction value. Everyone got it? Can you please confirm the chart? Y bar is it average of actual output? Yes, ma. Y bar is the actual out average of actual outputs. Correct. Because Y bar you can use when you will apply Y bar before you apply the linear regression, right? So average actual output value. Hmm. This logic say. There's the biggest mathematics is there again. Okay. A square equal to B square plus C square never equal. Okay. There's the biggest mathematics there from here to here. From to here to here. I'm skipping that mathematics. I'm skipping that mathematics and you will not find any textbook that is. Okay. You'll not find anywhere. You will not find any textbook. Just they will write sum of square total equal to make you to understand that is. They're like around 3-4 pages mathematics is there. That is. Yeah, this is the very, very biggest mathematics because a square equal never equal to b square plus c square, right? But a equal to b plus c, that kind of equal, we can do that like this, right? That logic say will start. What is the logic here? You see, now a minus c, equal to combination of, can I combination of a minus b plus b minus c, can I write? Yes or no? This combination. Now you see here. From here to here, okay, that is nothing but a minus c equal to combination of AB, combination of BC. That is nothing but A minus B plus B minus C. Now what is A? Tell me. Yi. What is C? Y bar. Now come to formula. Yi, Y bar. Okay. Now same again. What is A? Yi. What is B? Y cap. Actual minus prediction. Okay. Next, what is B? Y cap. What is C? Y bar. Like that. So that's why sum of square total equal to sum of square residuals plus sum of square errors. Now come to this again. Now divide with the entire formula with SS total. Divide this with SS total. Divide with SS total. And divide it with SS total. Everything. Divide with SS total. Divide with the SS total. This is the formula. This is the formula. क्या होता? Who is that? Yeah. Formulas are writing very difficult here. Today new batch starting 10:30. So your class is always at 10:30 close. What happened now next year? Tell me what happened next year? Hmm. This will gone. 1 equal to like this. Now this equal to 1 minus this. Not on this. And this is the Bola Venki. See, Venki now got R square formula. Very, very important interview question. This is called R squared formula. It is called R square formula. Sum of squared residuals, that is called SSR, and total sum of squares. Total sum of squares. SST. And that formula This is the formula. R square also called coefficient of determination. Coefficient of determination. We'll tell about explainability. Explainability of y. R squared will provide how much target variable explained by input variables. R squared will provide how much target variable explained by input variables. How much target variable explained by input variables. Suppose R square minimum value is equal to 0 and R square maximum value equal to 1. What? Suppose assume R square is equal to 0.7, which means input variables explained about output variables. Input variables explained about output variables is 70%. With a 70%. R square value equal to minimum how much? 0. Maximum how much? 1. So assume that R square is equal to 0.7. That means 70% your input variables are explained about y. That is good generally. That means sales equal to not 70% off. You and me both are very, very close. How much you know about me? How much you know? You don't know anything. You know how much? Rate something. So you know 50% about me, you know 30% about me, you know 20% about me, means you and we are not that much close. Suppose my wife knows about 100% about me. Okay. Assume that. Then we are very close each other, no? Like that. Your parents are knows about you. How much they are explained about you. No, correlation different. How much they are related. How much, it is a combination of variables, no? Correlation is what happened. Variable versus variable. But here what happened? All combination of how much this 9 o'clock batch are explained about Omkar sir. Entire thing. How much this 9 o'clock batch explained about Omkar sir personally. Okay. How much this 9 o'clock People are explained about me. Omkars are about, training wise. That is, there are different bars will be available, right? Now, this all people are explained about me 50%. That is called R square. Only Saurav and me have a relation that is called correlation. That is called core. But all this is, that is nothing but, suppose B naught equal to beta 1 into TV plus beta 2 into suppose social media. Now this you identified, assume that you identified true regression line, you identify the coefficients, we identify the coefficients. Okay, we identify the coefficients and we got the line also. We got the line. And after the what the line, we calculated the R square also. We calculated R square. R square is equal to 0.8. 0.8. That means this TV and social media are explained about sales is very well. This TV and sales are TV and social media are both are kind of important variables. Both are kind of important variables. TV and social media. So I can write TV and social media explain about sales with 80%. So they have 80% able to explain. They're 80% able to explain, which means TV and social media both are good variables. Suppose R square is equal to 0.3. That means they are not at all explaining. That means that are not important variables. That are not important variable. That is called R square. That's why R square is very, very famous. R square will give that how much you are explaining about output. How much you are explaining about output. There is no bar. Voice is breaking. Can you please confirm the chat? Everyone? Is my voice is breaking or voice is good? No breaking, right? Yeah. Then please check your internet, Nikita. So there's no bar, ma. 75%, 80%, 89%. There's no bar. Okay. Of course, low is very, very, we know that. Low is very, we know that low is very, very bad, that is. But more than anything, 70% when you started, right? It might be acceptable, might not be acceptable. We don't know that. Based on the use case only, we can know that. Based on the use case only. If you are created a model, you want to identify everyone's face. There are 100 members are there. You are identify 99 members. One person is gone. It might be impacted. Trainer only gone. Only students also says that is impacted, no? Like that. But it is 99% it is accurate, it is identifying. So we can't, that is based on the problem only we can identify. That is. So that is there's no bars. So that is R square story. R square will give about explainability. That's why it is called goodness of fit. What we call is called goodness of fit. It is called goodness of fit. We'll do simple calculation. You'll understand. Okay. Just do fatafat. Let me find if I can find anything in Google. R squared formula. Okay, Newcastle University. I will tell you. So let's take this example. Y bar is equal to y bar equal to 0.13 plus 1.229x. Please note down very fast. You can take like this if you want exact definition like this. You can take like this. 70% of variation in output is explained about input. This might should very, very accurate. Yeah, this you take example, definition. 70% of variation in output is explained about input. How much a person know about you exactly? When you will be happy, when you will be sad, when you will be frustrated, when you will get short temper, all these things, no? Who knows that? Hmm? Only family members knows and best friends knows, right? That's why their explainability very, very high. Okay, if you go dead, what happened? It not be come out in 1 week or 2 weeks, month, right? Maybe you can act. That is. So that is the wrong model. Finally, you'll break. 70% of variation in output is explained with about input. This also, we can say that 80% variation in sales, 80% variation in sales explained by TV and social media. That's the definition. That is the definition. Yeah. You want sweets? Hmm. Hmm. You want sweets? Chalo. For the first point 2 comma 2. First point 2 comma 2. First point 2 comma 2. Calculate. First point 2 comma 2. X equal to 2, y equal to 2. Write it. X equal to 2, y equal to 2. X equal to 2, y equal to 2. I'm writing the equation here. This is the x and this is the y and this is y predictions. Okay. This is the x and this is the y. And the equation, what is the equation, Isma? Y cap is equal to 0.13. So y cap equal to 0.13. Okay, let y prediction. Okay. Y prediction equal to 0.143 plus 1.229x. So x is equal to 2, actually equal to 2. What is the prediction? That is the first point. And 3, comma 4 is the second point. And 4, comma 6 is the third point. 4, comma 6 is the point. And 6, comma 7. One more point is there, what? 6, comma 7. Note on this. 6, comma 7. And the output value, first value is, the first value is 2.601. 2.601. And second point is 3.83. 3.83. And third point is 5.059. 5.059. And fourth one is 7.517. Note on this first. What of it? Note on that. And calculate the error here. Calculate the residual, everyone. Calculate the residual. Do it, ma. Of course, this will taken by Python code, but you need to understand it. What is happening inside? Do it. 2.601 minus 2, 3.83 minus 4, 5.059 minus 6, and 7.517 minus 7. So first one is, anyhow you do square, na? Okay, do it. What should I do with you? Saurabh, tell me. 2.601. Anyhow do square, no? Saurabh, then क्या फर्क पड़ता? 3.83, 6 minus 5.059, 7 minus 7.517. Anyway, you do the square, don't worry. First one is what happened? Minus 0.601. And second one is what happened? 0.17, no? 0.17. Third one is how much? 0.941. 0.941. Fourth one is how much? Minus 0.517. Next, what you have to do? Square. Square it. Square of the residual. Square of residual. That means 0.0.6 क्या होता आंसर? 0.6 into 0.6. I will take the calculator. 0.601 into 0.601. 0.36. 1210. 0.361201. 17 the 289, na? Then 0.289, na? 0.17. 289 only, no? 0.0289. 941 into 941. How much? 0.88541. 0.55 is 25, yeah? 517 into 517. 0.267. Add karo. What is the total of this? What is the total? That only formula, right? What is the formula? See here. Yi actual predicted square add. Everyone understood that is? That is the formula, right? Add it. 0.36. 0.361201. Do it. I know a value answer. 1.542871. It's called RSS or SSR, sum of square residuals. Next, average. What is the average, ma? 2 plus 4 plus 6 plus 7 by 4. Y bar. Average. Y bar. Average of output. Average of actual outputs. How much? That's called 2 plus 4 plus 6 and 7, which means 2 plus 4 plus 6 plus 7 divided by 4. How much? 4.75. 4.75. And what is the formula? yi minus y bar. Y minus y bar. Yi minus y bar. Yi means y bar. Are you following me, everyone? What is the formula, ma? Next formula. This one, right? You need to identify. Yi minus y bar. This one. Yi minus y bar. That means this is a y bar. If you take it, this is a y bar is nothing but what? 4.75, 4.75, 4.75, right? So y bar is nothing but this is a y bar. This is the y bar. The 4.75, right? 4.75, 4.75, 4.75. Everywhere is the 4.75 only. That's the y bar, correct? Shravya? Now, y minus 2 minus 4.75. 2 minus 4.75. And next, 4 minus 4.75. 6 minus 4.75. And 7 minus 4.75. Correct? Because yi, who is yi? Actual. This is yi. The yi. This is xi. This is y predictions. Y cap. So residual is equal to that you are doing what? Yi cap minus y bar. These are residuals. This is nothing but y cap. Again, what you have to do? Square. This is called nothing but explain, right? Explain thing. Again, you have to do the square of that. Again, you have to do the square of that and sum of this. You have to do the square of these values. Square. Tell me, Deepak, 2 minus 4.75, how much? Minus 2.75. And next, 0 minus 0.75. Next. If you do, then only you'll understand how internet will works. Next. 2.25. स्क्वायर करने तो क्या होता 7.5645. Next. 0.5625. Next. 1.5625. Next. Next. 5.050625. Now add करने तो 14.75. This, huh? Now this. Now what you need to divide this? You need to divide this by this, right? You need to divide this by this. 8 more JNTU question. Like this only, na? 8 more JNTU like this only. If I would have been like this age, no, if I choose data science, 4 years, so much we can learn data science. Now, this value. Are you following everyone? you're not following, please ask me, ma. I will repeat again. We are not doing for time pass. This is what this answer. Let's see. 14.75. Yeah? Ma, correct your. Next. What is the formula? 1 minus this value is nothing but 1.542871 and this value is 14.57. What is the answer now? 0.8954. That means how much the explainability now? 89.5. This means the number of lectures per day account 18 variation hours people. Okay, this is the question. The question is another question here. Forget about that, but you see here 80% is almost touching, right? This is okay. This is little. This is okay. This is little. It's going very good way actually, this line. That means how much variation is there? 89% variation. It can explain this line about the output values. So by seeing the value also, you can say that it is a very good or right? Where the question here? Number of lecturers per day affects the number of hours spent in the university of day. What they're saying that how the just should write here. How the number of lectures per day affects the number of spent at university per day. What is the meaning of this? Tell me. What is the meaning of that? How the number lectures per day affects the number of hours spent university per day. Finally saying this. This means the number of lectures per day account for 89.5 variation in the hours people spend at university per day. That is. Forget about this. The question is not clear, but you can say this here. What you can say? Tell me. Variation in output can explained by input. 89%. You can say that 89.5%. Variation in output can explain by input. That is the meaning. So this is the way generally R square will calculate. So now tell me what is the R square formula? 1 minus sum of square residuals by sum of square total. What is sum of square residual? Everyone knows, right? Sum of square residual means actual minus prediction. Next one is what? Total means what? Actual minus y bar. That means before your regression, after your regression. You are comparing with the two models. You are comparing the two models. Before regression, what is the model? Average model. After regression, what is the model? Linear regression model. And what you are comparing always with the original actual output. So actual minus prediction only we are doing. Actual minus prediction only doing. And that actual minus prediction. Suppose these both are equal. What is the value? 1. If both are both are equal is a 0, right? Your original value, your prediction value, both are equal to 0. Now you see here, this entire value will be 0. The summation entire value will be 0. That means exactly it is matching all the output and predictions, right? That is exactly matching. Let's discuss about that. That is a very, very interesting topic. Now coming to the numerator, suppose this value equal to 0 means then your R square value will become what happen? 100%. So this is exactly equal to mean that is exactly Bakwas model. Okay. That is exactly equal to mean that is exactly a waste model. Okay. No model will give 100% accuracy. Okay. Whether it is a human being, where the AI mission, it never be 100% accurate till now. That's why it is exactly equal to 0 means that is exactly waste. That is exactly waste. Hmm. I wrote wrong. 14.75. But you understood, right, Shankar? Then that is good. Here. Thank you. So you will write some bullet points here. Okay. No model will give 100% accuracy. That's the first thing. And second thing is, if you get error is 0 or model accuracy is 100%, and that is called overfitting. What is called overfitting? R square value keep on increasing when you add more variables. For example, you have only two input variables, that is equal to x1, comma, x2. For that, the R square is equal to 0.75. Okay. When you have three input variables, x1, x2, x3, R square value might be 0.85. When you have four input variables, x1, x3, comma, x4, R square value will be 0.95. Will keep on increase when you add the variables. The R square behavior, that is. Because I have one friend, you explained me about 50%. I have now two friends. You both combinedly explained about me 50% or more than 50? Definitely more than 50, because I can drink with you. I can eat chicken with you. Okay. But you don't know about me, I will drink with you. And you don't know about me, I'm a non-vegetarian. But when you both come and discuss, अरे ओंकार drink करने के लिए and ओंकार भी non-veg है. That means explainability is very, very more. You can explain will be only 50%. But when you combine both, what happens? The explain will be more increase. Like that, you have more friends, they can explain me about more. That's why when you want to search a groom or bride, then you go to their surrounding neighbors and will explain, no, how much they are explainability. That is. If you inquire more people, then you will get more, right? Same logic here. Same logic. If you keep on more variables, then what happens? The R square will be increase. But when it is reaches 100%, and that model will what happen? Overfitting. The model will what happen? Overfitting. Huh? 100%. 100% you will getting because of not understanding the patterns, because of your by hearting the question and the answers. Tomorrow a new data will come, then you will gone. A new prediction fail. This is a training, no? We are doing only training. In the training, you are getting 100% means you are just by hearting. You are not understand the patterns. But now, suppose Saurav is thinking like that. Saurav thinks, sir, more r square is more r square. My model is good, right? Generally, but some extent. But Saurav doesn't know that. More r square, my model is good. Then he thinks that he has 100 input variables are there. He applied all 100 input variables. Okay, suppose he has 100 input variables, and he used all 100. Then he got r square is how much? R square is equal to 100%. Then he felt very happy. Then Saurav felt very happy. Then he want to test his model. He felt very happy. Then he wants to test his model. Then he passed the test data. Then he passed the test data. Then he passed the test data. When you pass the test data, it gives a weird output. Then Saurav fuses blast. That is. अरे वो इनपुट में 100% आएगा यहाँ, वो टेस्टिंग में it is giving a weird input. I'm passing identify a boy image. It's saying it's girl. Huh? That is the kind of a weird inputs you will get. That means your model got overfitted. Your model got what happened? When you are training the model, when you are training the model, when you are training the model, which data will use? Train data. Which data will use? Train data. So the train error is very, very less. Very, very less. When you apply the test data, then test error, right? Then test error is very, very huge. Very, very huge. You feel very happy here. I trained with good data. My training error is very, very less. So I got a good model. But when you pass the test data, it's giving error is very, very high. So this kind is called model is overfitting. That means model is by hearting. Model is, I given 5 questions and 5 answers to you. I ask you to tomorrow exam. Okay. What you thought? Sir maybe given only 5 questions in this, and you by hearted 5 questions today night. But I given the 6th question. I given what? Then you gone. You learn only 5 questions. Then 6th question you're not able to write. That is called overfitting. Is a good model. What you will do? You will understand the 5 questions. What is the relation? For this question, why only this output? Then he might give the about 6th question. That is a good model. Understood? So tomorrow we'll talk about the overfitting and underfitting, everything. That is shallow. When you hand over the client, right? He will again come to your office. मुझे पैसे वापस दो. Like that. Understood, my everyone? What the overfitting means? Yeah, tomorrow we'll see that. Okay. Thank you. Thank you so much. Our class,